तो वो बोला मुझे, हाँ उसमें आपका जो 5 मिनट बस। अच्छा अच्छा, लैपटॉप नहीं है? हाँ, और लैपटॉप यूज करना है आपको? नहीं। फर्स्ट लेट मी नो व्हाट्स द टाइम टू टाइम। मैम टाइम कितना है सर का? 15 मिनट। अरे हाँ ठीक है, फाइन। हाँ लाइव बस। Tell me about it. Thanks a lot, all the organizers, to get me this opportunity to be with the esteemed scholars of engineering, medical sciences at Sgt University. As imparted and conveyed in very beautiful words by the chief guest of the event and the other key persons, I assume that all of you are from engineering stream, mechanical, all three. Computer science also? How many from computer science? Great, that's fine. Okay, then let me go in a very, that's your very mutually interacting mode of discussion. Otherwise, there is no fun of going for this sharing. And when I'm looking at the theme of the event, that's your international conference on mechatronics and artificial intelligence. It reminds me one of the beautiful couplets, if Urdu shair. शकूने दिल से एतमाम तो करूं, जरा ध्यान से सुनिएगा, सकूने दिल से एतमाम तो करूं, जरा नजर उनसे मिले सलाम तो करूं. And now I'm commenting on the theme of the conference. शकूने दिल से एतमाम तो करूं, जरा नजर उनसे मिले सलाम तो करूं, मुझे तो होश नहीं मशवरा दीजिए, ये फसाना कहां शुरू और कहां तमाम करूं. So the theme of the event is so wide that what to leave, what to skip, and what not to cover. But since I have been given the mandate as a part of the protocol of the conference, and I have also shared my brief write-up for the learners in the form of the message as well as the keynote address, that is machine learning inspired intelligent space. opportunities and challenges. Friends, as Professor Abid shared with you Industry 4.0, but being a student of your diverse disciplines, we also need to understand the importance even of the transformed learning and education that is being aligned with Industrial Revolution 4.0. And that is happening. And we all have been part and parcel of that huge transformation that has gone along with during this very hard times of COVID-19 crisis. And I am just trying to remind you of what Education Revolution 4.0. Because it's not by education, the teacher is the almighty who comes, shares, and moves. And even you as a student are not bound to be only confined to classroom teaching. And it's all the teacher communicates, you 100% agree to. So you should not be confined alone to our four-wall classroom, but rather more important is what? Today, our 21st century student needs what? Primarily three kinds of skills. Three kinds of skill, friends. The first, the foundational knowledge. The foundational knowledge, it devotes largely on what to know. Second is humanistic. Humanistic, your knowledge that pertains to the life skills. Not necessarily each of you would be joining some job. Maybe you are the person who could be fetching jobs for others. You could turn up into an entrepreneur, successful entrepreneur. And the life skills are quite important from that perspective. Third kind of knowledge and parameter for a successful 21st century student, learner, is what? The meta-knowledge. The meta-knowledge is important from a very broad perspective of an individual. Even our chief guest of the day was also referring to certain examples, the innovation, the creativity, even observed and exhibited, even by kids. Why it can't be practiced, even at a higher level? Friends, why I'm sharing all this? Because I certainly had a very long exposure of your international, because I did my postdoctoral from Brunel University, UK. And even in 2019, I was one of the senior professors from Government of India. We happened to learn those kind of skills which are indeed needed in our Republic of India. And we were just exhibited, we were just exposed to the experience at Cambridge University. Why am I referring the name of the Cambridge University? Can you name me any university in our country which have fetched even a single Nobel Prize? And let me take that statistics in terms of to showcase the innovation exhibited by our Indians. You know, till date, how many Nobel Prizes, I think we would be having a roughly idea, since the foundation of the Nobel Prizes world over, how many Nobel Prizes so far have been given away? About 898 Nobel Prizes. And you know what the population of our country today? 135 crores. And if you're talking about China, 1.41 billion, that is 141 crore. If you are talking about the total population of the world, 7.83 billion. And you just total this percentage, we are the two countries which should also contribute intellectually too in research and development. But you will be amazed to know that what is the share of Nobel Prizes? To credit to India, only 12 Nobel Prizes. To China, only 9. And we are talking about United States alone, 353 Nobel Prizes. If we are talking about United Kingdom, a small country having much lesser population even than Uttar Pradesh, having about 143 Nobel Prizes. And out of those 143 Nobel Prizes, alone to the credit of Cambridge University, 107 Nobel laureates. And we had a live exposure to meet about this Nobel Prizes of 2018. They were from chemistry department. There is one very specific lab at that's your Cambridge, that is called Cavendish Lab. The people working, I'm simply talking about, I'm just, if my simple sharing, it could inspire even of the couple of the young brilliant students, that will be enough. So what I'm trying to convey, that simply coming to the institution, just appearing in the examination, only for the sake of clearing your, or just getting your degree, I think that is not likely to serve the purpose. The purpose, it ought to be very different. That you should be a transformed learner with the skills I just shared with you, attaining good level of meta knowledge, your foundational knowledge specific to discipline, and also apart from more important, that is those kind of life skills. If I'm referring what is happening in our surroundings today, you know, digital transformations, that has played a very important role, but it did not happen overnight. I think you all had been even subjected to your online teaching, learning during this our COVID-19 crisis. And also, even all teachers contributed. Neither the teachers nor the students, they are the volunteer contributors to this. It was a forced learning. It was a forced learning everybody had to witness, and everybody had to be part of that. But if you are talking about a new education policy, as per new education policy 2020, 20% of the credits, it could be earned for your online courses. Why I'm showing this? This our digital transformation has not only hugely and heavily impacted and influenced only education sector, but all walks of life. If I could share with you, when technology disruption takes place, the disruption, it is not a refined technology, but that innovation, when it is realized in reality, that becomes of social relevance, right? If you are talking about, do we have even also currently some innovators? Yes, friends, there are. And you could be also one of those, and you could also be practicing and doing several kind of innovation. Innovation is not like a kind of spoon feeding, that it will show the magic overnight. No. But it is your habit of valuing a good thought process that could be leading to somewhat very creative. And as well quoted by the great motivator of the world, at least for younger generation, APJ Abdul Kalam, he has beautifully correlated the creativity and the knowledge. What he says? Learning. Learning leads to creativity. Creativity even helps you to motivate more and more. And that leads to what? A thinking process, thought process. And the thinking process ultimately helps you to acquire knowledge. This is how learning, creativity, thinking, and knowledge, they are interrelated, they're intermingled. And if I could share with you today, the word AI is not a new word. It was, this term was initiated by John McCarthy in 1960s. IBM came with a deep blue machine that defeated the world chess champion, Gary Kasparov. Another example, also our learned colleague mentioned for WhatsApp, but that's your Watson. But let me tell you, friends, I'm just referring few examples for you. How many of you have heard the name Pranav Mistry? Have you heard the name? Please raise your hands. Great. But I'd like to make a mention. He was also from a very moderate kind of, very middle level of engineering college. From Gujarat, from Anand. He was also a BTech student. But had the lust of innovative ideas. You know how many credits are to his, how many patents are to his credit? Six patents to his credit. And 6 Sense technology was the brainchild of Pranav Mistry. Today, when you are just using a smartphone, you are just putting zooming in and out. Even you are just putting the different objects here and there. This was his brainchild. And you know, at the age of, he's just only 40 years. At the age of 40 years, he is signed, that's your senior vice president of Samsung Group. At the age of 40. Let me also quote another name. Arnav Kapoor. Arnav Kapoor, who had been a student of one of the institutions in India, later on, he got an opportunity to work with MIT, United States. He came up with a particular device, what we are thinking here at your brain. It could pronounce and it could help you to act accordingly. If, for example, I'm moving there, it means my brain has generated a signal and making my eye to point that. But how it will capture? That is your inside movement. Even that movement could be tapped and you can take an action. For example, I'm interested to know, I'm just walking. I'm interested to know what's the time. I'm not speaking, but even my thought process inside goes as I'm interested in knowing the time, what it should. Maybe automatically a speaker, it should get you, it is this much of time. Think of. These are the kind of small ideas. And I'm telling you, friends, when you start thinking and coming out of the box, confined, bound by the curriculum, it is not going to help you much. You know what happened? There was one of the teacher assistants of Albert Einstein when he was a professor. Then he asked, give this question paper to the students. He asked the technical, teaching assistant to distribute the question paper to students. Then the teacher assistant asked, sir, is it not the same question paper that you just gave to the students last year? What was his answer? Yes, question paper is same, but the answers have changed. Friends, what are the problems? The problems that we had, the society was needing or looking for solutions 10 years back. These are not the same as we are facing today. Because since you all the students of your engineering, IEEE Computer Society that publishes, that slates its agenda for an year, what they are going to contribute throughout the year. They have just pronounced the agenda, what they are going to cover this year, and will come to realize there are 3-4 things which will set the landmark in the engineering discipline. Like Professor Abid was just mentioning, additive manufacturing. Because there have been few things. I'm just mentioning another one. Digital twins, augmented reality, your edge computing, your adversary learning, your maturity of deep learning. These are some of the very important new areas which are going to land in the different fields of your engineering in the name of your multidisciplinary approach. And I'm pretty sure this is going to help. If I could share with you how our digital diverse, it has grown. It has gone with a substantial growth. I'm simply talking about, if, for example, if you take a stock of last 7 years, within last 7 years, it has moved from 4.4 trillion gigabytes to 44 trillion gigabytes. That means, our trillion gigabytes are nothing but equal to 1 gigabyte. So the size has gone 10 folds within a span of last 7 years. If you are talking about whatever the mobile traffic, it has increased in the last 7 years, 220% of the mobile traffic, it has gone up. And when you're talking about your cloud, which is there to help us all across, what is the total size it has gone? It has gone from 20% to 40% of usage in the last 7 years. So this is the scale of our digital universe. And one more thing I would like to mention. If you are talking about in the time to come, unless you are a smart engineer, who else would contribute the smart cities for tomorrow? No one can. And in order to go for a sustainable development, what you ought to have, what exactly needed to run a smart city? Power. And what the major chunk of the power is likely? From the solar. Your IoT, Internet of Things or Internet of Everything, it is not going to help much unless we could sustain on the power. And I'm just letting you know, your government of India, it came up with that provision of setting up smart cities in the year 2016. And what it was? Only with 20 cities it would have. Later on, it was scaled up to 98. So how many total smart cities are likely? The mission was about to be completed by 21, but it has been pushed to 2023. And if you are referring, Div is a small state. Is your 100% running on solar power. Karnataka is the largest state that is producing solar power. There are 242 national level solar parks. So that is the energy bank. That's fine. I also got a hint from Ajay, who's a smart boy. I can't deny him. But yes, of course, my purpose of sharing the thought was just to inspire, to motivate all our young faculty members and all the students. Because when you are referring your machine learning, deep learning, AI, it is a step beyond. But still for the, for computer science students, I would like to make a mention of a few terms that do need to spend time. Go for data lakes. I'm just sharing with you data lakes. That is a step beyond data warehouse. digital twins, very important, that will certainly be as a part of mechatronics, and AI is going to help. You know, the entire our Singapore Development Authority, they have created a digital Singapore. It's a complete replica of the entire physical system. And that is why Industrial Revolution, your Industry 4.0, that is devoting much onto what? Cyber physical systems. But how do you, for example, if I have to make this finger movement, I could tap from here and it can start functioning. That's a digital replica. And what to talk? When we used to talk about the big data, we used to say there are 3 V's: volume, velocity, and variety. But today, when you look how it has moved, 10 V's co-determine your big data. It may be the value, it may be the variability, it may be the veracity, it may be the vocabulary, and so many things. And what to talk? Our cyber crime also has come to help, even as a service. People are using as a service. And the cyber criminals, they hit the important assets. They damage it. You know what is the total cyber crime damage approximate comes to? It's expected by 2022, it is going to be $6 trillion US. And what is the total revenue that is generating right now? $1.5 trillion. That is the income revenue. On one side, this is the income. This is the cost that we are paying. And cyber, your crime is being used as a service. So cyber security. And lastly, one thing I'd like to make a mention: AI, machine learning. It has also started assisting and helping, even curbing our cyber crimes. Right? How? Because anybody who just try to penetrate or to filter, to enter, it will be looking into the trends. Your machines are they are trained for that data. And it can, before that, it can get you a signal and you can be ready for that. With all these words, I conclude, and I thank everybody for giving me a patient hearing. And I also thank Professor Manish, Dr. Ajay, and the entire organizing committee to get me this opportunity to interact with you all. Thank you very much. Thanks a lot.
Thank you, sir. We are forever grateful that you shared your experiences and skills with us. We are so touched by your intellectual words. Thank you, sir. Thank you so much.
Now, I would like to invite Dean Sir, FEAT, Dr. Manish Mahajan, to present Certificate of Appreciation to our Honorable Keynote Speaker, Professor Naseeb Singh, sir. Thank you, sir. Now, before calling upon one of the most distinguished personality we have amongst us through online mode, Mr. Himanshu Goyal, I would be privileged to introduce him. He is a passionate entrepreneur who aimed at enterprise software sales, big data, weather forecasting, and many more. His company offers accurate business solutions. It owns Weather Channel. It has vast experience in corporate as well as marketing sector. Okay. Due to some technical errors, he won't be able to join us. So I'd like to give Jaya the chance of introducing Krishnan sir.
Now, I would like to introduce Dr. Kumar Krishnan, Senior Scientist in NASA. Dr. Kumar Krishnan holds the appointment of Adjunct Professor at the University of Houston, USA, Honorary Distinguished Professor at the MIT University, Haryana. Dr. Krishnan was nominated by Governor George W. Bush and confirmed by the State Senate of Texas to the Texas Board of Licensure Professional Medical Physicist in 1999. I welcome you, sir.
The host has to let me in. It says host disabled participant screen. Am I, can I share my view graphs on the screen?
Yes,
So-
sir, you can share.
So
You are given rights to share.
okay, let's try this first. Let's try this, see how it works. These are my view graphs. So how can I share them?
So you can share your screen.
Share the screen. Okay, share the screen. Now, do you see my view graph?
Yes, sir.
Is it coming in full view or? Okay, hold on 1 second. Let me see here. 1 second. Okay. Okay, are you able to see my view graphs? Are you able to see my view graphs?
Yes, sir.
Okay, let's go then. I'm, you know, so thankful that to get this opportunity. It's only 2:30 in the night. I'm located in Houston, next door to Johnson Space Center here. So students, I hope you will not get hungry. I'll try to finish in about 20-25 minutes. That's the allocated time. You have this international conference on mechatronics and artificial intelligence. And let me make quickly 2 or 3 comments, okay? A, we're going to see space sector quite a bit coming to life in the next few decades. You're already seeing China getting the samples from moon. You're seeing a lot of activity going around Mangalyaan. Chandrayaan is going to be a staging place for many things, including laboratories and what have you. And you are seeing Gagayaan is going to be occupied in many ways, and people are going to be visiting up there. Now, having said that, going to space is not an easy thing. First of all, you have to cope up with the atmosphere or the way the surrounding is, vacuum, for instance, lack of gravity in some case, 18% on the moon, 38% on the Mars. These are just minor things, but then you have the cosmic radiation, nuclear particles, and so on and so forth. Then you have to minimize the weight, size, power consumption. All of these things from Apollo time to this time, I have become a student. I'm simply a student of space technology. And every day I am learning more and more. So the greatest challenge is for the systems to work in space, on the moon, on Mars, or on asteroids, or wherever we are going to go in this universe. Now, having said that, these machines and systems have to be intelligent, they have to be agile, they have to have self-diagnostics, they have to be self-healing, because we don't have people, armies of people to service these. So that independent systems have to be developed. This will call for this mechatronics, very little weight, very little size, very little power consumption. Then I don't use artificial intelligence. As a student, I use transferred intelligence. From the day we have been working on Apollo to this day, all we have done is made machines capable to take our intelligence and use it, maybe extrapolate in certain ways, maybe not get fatigued, for example, and so on and so forth. So now, having said that, that's the talk I'm giving today has to do with the new technologies and that have potential for space. And this will have automatically potential for Earth, here on Earth. Anything we have done in space has come back and helped us here on the Earth, revolutionized our industries and revolutionized the way we are living, revolutionized any sector, medical, transportation, anything. Now, having said that, last 4 years before I retired in 2018, end of 2018, I was given the job of finding what are some new technologies that we should be working on, Kumar, for going to moon and staying there for a longer period of time, going to Mars and coming back, things like that. So that's not a small order. So I developed a process that allowed me to take all the knowledge from anywhere and everywhere in the world, including different centers in NASA, the different departments in United States Department of Defense, for example, energy and so on. I examined all these and tried to give a coherent methodology for the selection of the top paying technologies for the space sector. Having said that, one of the great things I had going for me is that I was responsible for reviewing documents generated at Johnson Space Center, which is at least 1,000 per year. For the last 11 years, I was doing that to spot out any intellectual property so that we could patent it and use it in commercial world. So that gave me instantly a little bit of a good start on selecting these technologies. Now, time is very short. The first thing I came down with was about 100 technologies. From that, I came down, I told you, we're addressing space sector. And space sector is not necessarily here on the Earth. Maybe I would select in a different way the technologies that we need here on the Earth. But this is addressing the space sector where I told you the environment is very different. There is need for independently working machines. Now, Quantum vacuum plasma thruster is where we take the particles like electrons, positons in the vacuum of space and make them behave and exhaust to get a kick. It's a concept at this time, and one of our scientists, Harold White, Dr. White, has worked quite a bit on it in the last 10 years and brought it forward. He is doing some work in the laboratory. I will not talk about that, but I will talk about variable specific impulse rocket, and that should give you a little idea about the other technology, vacuum, this Q thruster. Now, one of the things that I learned the hard way is that if we have to stay in space, we have long duration missions like going to Mars will take 10 months or so, coming back 10 months and staying there 10 months. That's 30 months. We have to have a regenerable, we have to regenerate our resources. Water, for example, will be consumed and then brought back to life again as potable water, something we can drink. Then all these bio waste to fertilizer and then converting it, maybe producing some crops and things like that. Heat is a big thing, managing heat in spacecraft. We have new technologies there. I won't be talking about all these technologies. We'll be here then for next couple of days. But the other thing, so I told you recyclable resources, how to recycle like we do on the Earth. There's a natural process, but in the spacecraft on the moon, on the Mars, we have to create these systems that will recycle any resources that we take. Then the second big thing is, what can we use from moon or Mars? It's called in situ resource utilization, and methane, which can be used for propulsion. Water is critical, and so water and oxygen, all these have to be manufactured. We need to have manufacturing processes to do this. Now, the next, I go to the next one, augmented reality. You heard, augmented reality is upcoming because for me, it's the way to be able to guide astronauts, to repair, to train them, to get them in touch with their families. There's a lot of applications. I developed a plan for the augmented reality for space missions. Expandable structures and habitats. Johnson Space Center did a lot of patenting on this. These are carbon fiber type of structures that collapse, and that's produces very little volume and weight, and then they expand, and therefore they have become very good for habitats in space and will be utilized on the moon and Mars. Dust has been a preoccupation for me. In fact, I developed some mathematical models for the dust storms on the Mars. But dust is a big issue in space, and we won't talk about all of these. We'll talk only 3-4 quick ones. Now, having said that, so let's go to the next chart. The next chart says autonomous systems. I was telling you, neural networks, deep learning will be put in these machines. As I said, I don't call this artificial intelligence. I call it real intelligence that we have taken from humans, combined them in a machine so that the machine becomes intelligent. Carbon nanotube technology, I'll talk about this. Coatings are very attractive. Composite structures that I was talking about are attractive because they could shield us from space cosmic rays and particles. IPMC, intelligent smart materials, I have a few on that. Superconductor technology, I have a few slides on that. I won't be talking about terahertz technology. All these technology, about 31, I had to go much deeper, and then NASA asked me to select only 8 of them. Today, I will talk about 3 or 4 of them very quickly because we don't have the time to do that. Now, when we come to superconductors, these are very attractive materials. You will see what happens in superconductive materials, that there is a critical temperature. Up to that critical temperature, there is no resistance. Therefore, there is no heat generated and no losses. And so that takes a new dimension. Next thing, people have worked on wires. There are companies here that have developed flexible yttrium, barium, copper, thin film type of coatings that can go in a conductor wire, and a lot of experiments going on right now. And some of this in the classified world may have been already used, but in the unclassified world, still people are not using a lot of these wirings other than in the computers and many specialized places. So I was the chairman for the World Congress on Superconductivity, and there's a lot of activity in superconductivity. There is this Meissner effect that two magnetic fields repel each other. When you cool this magnet with liquid helium or liquid nitrogen, that itself gives you levitated trains. These have lots of efficiencies, and you're almost becoming an airplane because you're not touching anything. For me, the two things that were big on my agenda that I recommended NASA is, one is propulsion for, like on the moon surface, if you have to come up, you can do this high temperature superconductors, and that magnetic propulsion can take you, and there is no pollution associated with it. The second application that I'm very excited about, and there will be an experiment in the next 5-6 years that NASA is going to conduct on the moon, is where you put this high temperature superconductors in a place where there is no light for years and years. So the temperature is naturally down all the way to liquid nitrogen. So there you store 10 watts, it will be 10 watts after 10 years. There will be no losses. That, when Director Dr. Cohen heard it from me 25 years ago, he said, Kumar, we need to work on this. And we started a big initiative at University of Houston on high temperature superconductors. Now I'm going to tell you the last. Squids. Squids can be made with this high temperature superconductor. What is a squid? It measures the least amount of magnetic energy, and that magnetic energy can come from the brain. Therefore, we can find anomalies in the brain like Alzheimer's, some other things that come with aging, like I'm aging, therefore my capability of thinking has been impacted, and we'll be able to monitor this. Now, there are other things are like detection of cancers and so on and so forth. So I gave you a little synopsis on this semiconductor, on the high temperature superconductor technology. Now I will give you a little synopsis on ionic polymer metallic composites. On superconductors, there are like 6 Nobel laureates. So on this ionic polymer, we have one Nobel laureate, D. Genix, from Paris, France. He found out that in plastics, polymers, there are little pockets that are empty. Once you put saline, some kind of solution in them, then you put a voltage between the two pairs of this sandwiched polymer, you put a little voltage, you suddenly see the ions or cations and anions go from one side to the other side. Therefore, like my finger, it starts to bend. That bend you're seeing here from the coin, and once you put the voltage in, it can lift about, in this case, it lifted 4 times its weight, but we have huge effort going on at University of Nevada in Las Vegas with Dr. Kim. He and I worked together on many of these things, and I wrote a paper for the application of this IPMC in space. We want to make snakes. We want to make flies that fly on the Mars, snakes that go on the Mars or moon, little grabbers, you know. And one of my concepts was that we could even make a suit that gives the capability for the astronaut to get exercise. Because at Johnson Space Center, we found out that by vibrating the bones, you can make bones stronger, make them to take calcium and potassium and so on and so forth. And therefore, you do not lose weight of bones like we lose in International Space Station. So this concept is given in my paper, several applications. The other thing that is very attractive about this ionic polymer, and I hope you're with me on this, is that it can sense small vibrations. And that itself is very good because it's a light material. You put it on a table, it will generate little voltage at it as it vibrates. That voltage can be amplified and made bigger, and therefore you can monitor. The second thing that was very attractive to me is then if something is vibrating in space, like in the International Space Station, we have a lot of vibrations and we can monitor these vibrations, then you can put against that vibration. So you can nullify that vibration. You can attenuate that vibration with the same device. Next, because time is running out, carbon nanotube. It's a big thing. Again, for the superconductivity, very near to me here, University of Houston, Dr. Paul Chu. Then on the IPMC, Dr. Kim from University of Nevada at Las Vegas. Now carbon nanotubes, Rick Smalley and two Nobel laureates came from Rice University on this nano tube. So what nanotubes are great about is they have very tremendous strength. Their electrical properties make them superconductors or semiconductors. Rick Smalley died a few years back. Bob Curl, I see him almost on a yearly basis, is still living. He is 90 some years old. These inventions, the invention of buckyball, out of which came the nanotube, was done by three people, one from England. Then these nanotubes have unique chemistry of carbon, which makes them thermally very high, like diamond. They can take a lot of heat, and that's very good for us in space. They have perfection, very versatile material. So let me give you a couple of examples. And this is in 2018, almost toward the end. My advanced microprocessor was built. So when I was pushing this technology, I was pushing it for reasons that it's less weight, it's strong, it can attenuate to some extent this radiation that we have and particles coming in space, and then it can take much more heat. But now look at this. We have a carbon nanotube technology that has developed into an advanced microprocessor, and it can compete with any microprocessor. And you will see in the years to come, many technologies, many systems will be having this carbon fibers and this technology. Now, I told you earlier that I will give you one example of this variable impulse motor rocket, and I'm sure you're able to see the whole flow. But in this case, what you do is you take helium or hydrogen, some inert gas, you ionize that, take one set of ions out, like let only positive ions go in, then you heat up that plasma, make it hotter and hotter, give it energy through magnetic field, and then exhaust, and you will get a kick, and that's called the Vasmer rocket. And what is so great about this rocket is it's a constant acceleration rocket, and it promises that we can reach Mars in about 4 months, cutting it down to less than half of the time that a, a normal rocket based on anything that we can come nuclear energy will take. Now, again, it's all based on physics, and we have been working with several individuals here at Johnson Space Center to have a experiment in the International Space Station to see how it works. So again, time is short, but maybe one of these days I get invited to talk about all these things in detail. But this variable specific impulse magnetoplasmic rocket is proceeding step by step, and we are doing tests at this time for seeing how long this can work. In other words, in terms of hours and days of giving us the propulsion. I believe this is the last example, wavelet technology. I'm excited about this, and this will have huge application in what I call transferred intelligence, intelligent machines. So what are these wavelets? And I'm sure you all know that. Sines and cosines are here on my left, and these wavelets are here. Davachi's developed them in 1988, and this is the orthogonal set. When you have an orthogonal set like sines and cosines, you use minimum of these orthogonal sets to describe a function. That's the beauty of wavelets. But in this case, if you have discontinuous data, such as an image, then wavelets have incredible application. Let me show you one such example. Is here. You have a triangular pulse on your left. And if you take 27 terms of sines and cosines, the problem is left and right of the triangle, you will see some residual fluctuations. Now you take 27 terms of wavelets, not only does it precisely do that discontinuous function, or at least it's not discontinuous, but it's a continuous function, but it has rapid change, but also see to the left and the right, there is no noise. So if you have to take an EKG, you can see you will need only a few of these components, wavelet components, to describe precisely an EKG or any changing phenomena. So what are some applications that we have in space? One of them is data compression. That is the big attraction that I try to get NASA interested in. Data is expanded, as you have heard from the other speakers. Trillions and trillions of bytes are coming through, and not necessarily all of that data is useful. Therefore, if you have an algorithm, compression algorithm based on wavelets, you'll be surprised how great it does. See here, if you look to the left, these fingerprints are now routinely analyzed by FBI here, Federal Bureau of Investigation, because they identify the peculiarities of the fingerprint much better than sines and cosines based. And therefore, you'll find that discrete cosines and sine transforms are way noisier compared to the sharp image with a wavelet transform. Look how fast I went, because I wanted to finish in my time. I was sent to United States by no other than Prime Minister Lal Bahadur Shastri. Therefore, I dedicate this quick talk to him, and he supported me by giving me all the money I needed to travel from Calcutta University Institute of Radio Physics and Electronics to Kansas State University in Kansas. And it was hilarious because first I had to go in a train up to Mumbai. From Mumbai to Mars, I had to go in a ship. From there, I hopped about 3-4 times to reach by plane Manhattan, Kansas. Thank you very much. I'm so delighted that I got this opportunity, and I'm hoping I will get more opportunities to go deeper and deeper into these technology, because that's what I spent my 54 years is a technologist and a student at Johnson Space Center. Thank you.
Thank you, sir. Thank you very much for your presentation. It was full of new technologies and it delivered example that was very interesting and informative. Thank you very much for your excellent presentation. Now,
Thank you.
yes, sir. Thank you, sir. Now, we will be commencing with the offline technical sessions. In this session, each participant will be given 10 minutes, and after that, 2 minutes will be given for questioning round.
Now, I would like to invite Dhaneshwar Singh for presenting paper ID 28, Cloud Computing and Mobile, the Age of Virtual Internet and Space.
Am I off? Yes, am I off now? Did you turn me off?
रिक्लेम होस्ट करता हूँ रिक्लेम होस्ट
Okay.
बस just hold. कर दिया
Good afternoon, everyone. Thank you very much for giving this golden opportunity to deliver presentation on mobile and cloud computing, the age of virtual internet space. As we all know that mobile and cloud computing are hand in hand emerging technology. It has evolved in back 1960s